A viable alien spaceship detector is here, and nearly habitable and water-covered planets have been found. For thousands of years, people have wondered, are we alone? Astronomers have now ascertained, statistically speaking, that every star in our Milky Way galaxy should have at least one planet, and that small rocky planets are extremely common. Our own galaxy has 100 billion stars, and our universe has upwards of 100 billion galaxies, making the chance for life elsewhere seem inevitable based on sheer probability. We can say that with certainty that for the first time in human history, we're finally on the verge of being able to search for signs of life beyond our solar system around the nearest hundreds of stars. Paul Sieber in Mysterious Universe states, "It's a great time to be a space scientist, as the latest space telescopes are allowing them to identify more Earth-like planets and planets able to potentially host life. These telescopes also help identify technological signatures that may indicate alien life using machines." All three of those events were discovered recently, making this a huge week for space science. First, two exoplanets with Earth-like masses were discovered, orbiting a dwarf star in its habitable Goldilocks zone very close to our solar system. Next, two large ocean worlds, composed largely of water, something rarely seen, were identified. And finally, scientists found a way to use one of the world's largest lasers to detect alien warp drives powering alien spaceships. Nature seems bent on showing us that Earth-like planets are very common. With these two, we know now 7 in planetary systems quite near the Sun. In a press release announcing a new study published in the journal Astronomy and Astrophysics, lead author Alejandro Suárez Mascherano of the Institut de Astrofísica de Canarias in Spain, Canary Islands, delivered the exciting news that Fermi's paradox, which says worries everybody, is becoming more paradoxical. He and other researchers at IAC recently discovered exoplanets GJ1002b and GJ1002c, orbiting the red dwarf star GJ1002. That's less than 16 light years from our Sun or our solar system. Incredibly, both planets have masses similar to Earth's, and both are in the habitable zone of GJ1002, which means they could potentially host life similar to that on Earth. Mascherano's astonishment that he and his team just upped the known list of Earth-like exoplanets from 5 to 7 means Fermi was right when asking, where are the inhabitants? GJ1002 is a red dwarf star with barely 1/8 the mass of the Sun. It's quite a cool, faint star. It means that its habitability zone is very close to the star. Co-author Vera Maria Pessinger explains that GJ1002b orbits the star in only 10 days, while a year for GJ1002c is just over 21 days. Despite that, they were able to be detected by astronomers using the European Southern Observatory ESO instrument, ESPRESSO, as short for Echelle Spectrograph for rocky exoplanets and stable spectroscopic observations, installed at the Very Large Telescope VLT in the Atacama Desert region of northern Chile, and the Carmenes Calar Alto High Resolution Search for M dwarfs with exo-Earths with near infrared and optical Echelle spectrographs at the Calara Alto Observatory in Andalusia, southern Spain. These instruments collected data on GJ1002 between 2017 and 21. Carmenes was especially well suited for scanning a dim star for exoplanets because it's sensitive over a wide range of near-infrared wavelengths, something no other Earth-based telescope has. However, it still needed ESPRESSO to confirm the two planets. Now that they know where the planets are, Mascherano and other astronomers plan to go to the Andes spectrogram on the extremely large telescope currently under construction on top of Cerro Armazones at the Atacama Desert of northern Chile to study the atmosphere of GJ 1002c. Take that, Fermi. A team led by researchers at the University of Montreal in Canada has found evidence that two exoplanets orbiting a red dwarf star are water worlds, where water makes up a large fraction of the entire planet. These worlds, located in the planetary system 218 light years away in the constellation Lyra, are unlike any planets found in our solar system. NASA announced that researchers at the University of Montreal published a report in the journal Nature Astronomy discussing their discovery of two water-covered exoplanets orbiting Kepler-138. That name means it was discovered using data collected by NASA's now deactivated Kepler Space Telescope. The two watery exoplanets Kepler-138c and d were discovered using NASA's Hubble and retired Spitzer space telescopes, and were two of the four planets orbiting Kepler-138. The methodology used to determine they were water planets involved comparing their sizes and mass to known planets, which revealed that their low mass and bigger than Earth size meant at least half of their volume was comprised of materials that are lighter than rocks but heavier than the hydrogen or helium, which are the mass of gas giant planets like Jupiter. That left them to conclude that Kepler-138c and Kepler-138d are covered in water like Earth, and unlike all the other planets in our solar system and most of the exoplanets discovered so far. It's the best evidence yet for water worlds, a type of planet that was theorized by astronomers to exist for a long time. Study co-author Bjorn Benneke, professor of astrophysics, University of Montreal, expressed the excitement of the team in making this discovery. However, Caroline Piolet from the Institute of Research on Exoplanets, University of Montreal, and leader of the study, cautioned that the liquid on these planets is not necessarily water, and even if it is, it's not necessarily safe for humans or other life forms. As she said, the temperature in Kepler-138d's atmosphere is likely above boiling point of water, and we expect a thick, dense atmosphere made of steam on this planet. Only under that steam atmosphere, there could potentially be liquid water at high pressure, or even water in another phase that occurs at high pressures, called a supercritical fluid. That eliminates both planets, since the researchers discovered, to their surprise, that Kepler-138c and d are twins when it comes to mass and size. That does not take away from their importance as the newest members of the small club of water world planets. That covers the new exoplanet discoveries. Another announcement this week has to do with spaceships intelligent life forms might use for travel between their planets and others in the galaxy. In a deeply scientific formulated field study published in the preprint database ARXIV, researchers led by physicist Luke Sellers of the University of California, Los Angeles, proposed that intelligent extraterrestrials would travel in rapid and/or massive accelerating spacecraft, which they called Ramacraft, potentially powered by warp drives, while any object with mass that accelerates generates gravitational waves. A huge galaxy galloping Ramacraft would likely produce sizable detectable gravitational waves. If these Ramacrafts were traveling at about 1/10 of the speed of light, the researchers determined they could be detected using US-based laser interferometer gravitational wave observatory LIGO, the current king of gravitational wave detectors, and in the future, the planned Deci-Hertz interferometer gravitational wave observatory and Big Bang observer will be 100 times more sensitive than LIGO and able to spot more Ramacrafts inside our Milky Way galaxy. Of course, as Fermi might say, possible does not necessarily mean real. We have not detected alien life on exoplanets, inhabitable zones, or water worlds, or in alien spaceships yet, but our technology is advancing at speeds that could find them soon. If they exist, for that moment of doubt, we can thank the late Frank Drake and his equation. Space Science Need More Optimists. And this is by Paul Seaborn on Mysterious Universe on Collective Spark. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box.